Hello and welcome to SudoKanard. We're here to solve this Arithmetic Pairs Sudoku puzzle, 6 by 6 and then 9 by 9, that was created by Indian author Nityant Agarwal for Sudoku Mahabharat. So the special rule is that whenever you have a number between two cells, it means that some operation, one of the four main operations, gives this result with the two digits in those cells. And Nityant has used a series of consecutive results. That's very nice. So the place to start is definitely this 11, which can only be obtained by 5 plus 6. But 5 doesn't work with 12. You can't add a 7 in a 6 by 6 Sudoku. So that's it. 10 won't be 5 plus 5, it will be 5 times 2. 12 will be 6 times 2, it won't be 6 plus 6. Now we're left with 1, 3, 4, 5, but the only way to get a 6 here is to make 1 plus 5. Next, this 7 here will be 1 plus 6 or 5 plus 2. But then to get this 8, a 6 here would make this a 2. But 2 is not available, so this is actually a 2. 2 plus 5, 5 plus 1. And to get this 8, I can't make it 2 plus 6 because 6 is not available. It would have to be 2 times 4. And we have a 3, 6 pair here, and this here can only be a 1, that's a 5. And to get this, that's a difference of 1 with a 2 here, and a 3, 4 pair in the column. Here, how do we get this 2? I think it could be 2 divided by 1. It could be 4 divided by 2 or 4 minus 2, which amounts to the same result. And we see that this can't be a 5, it can't be a 6. 6 wouldn't give a result of 3. So we get a 5, 6 pair here, that's a 1. That's a 3, 4, 6 triple. So 6 is here, so this is 1, 3, or 4, and all of them are possible. It could be 3 divided by 1 or 4 minus 1. Let's move on to this. With it couldn't be 6 divided by 2 because we have a 2 here. But it could be 6 minus 3. It could be 6 minus 3 the other way around. And actually, it could also be 3 divided by 1. But my actually was about what's happening in here. We won't have 5 divided by 1. We won't have 6 minus 1. We won't have 4 plus 1. I think the only option is to have 2 plus 3. And then this 4 will be done with 3 plus 1. So that's 3 divided by 1, and that's a 6. Here that's a 4, so 4 minus 1. Then this can only be a 6, 5 and 6. And the n is just standard Sudoku. Like this, 2 and 5, and 6 and 4. That's working. So now let's move on to 9 by 9. So here again, Nityant has chosen consecutive triplets. That's really very nice setting. And there again we have a natural beginning with the sum of the highest 2 digits. 17. 16 could be 8 times 2, but 2 here wouldn't work with the 15. So it will have to be a sum, and only 9 plus 7 is possible. And this 15 is now 7 plus 8. 10 could be 4 plus 6, could be 2 plus 5. This 14, it can't be 9 plus 5, it can't be 8 plus 6, so it has to be 2 times 7, and there again 2 doesn't work with 15, so that's a 2 and 7, and that's 7 plus 8, and this 16 is 8 times 2. So we have a 2 somewhere here, but 2 with 11 would require 2 plus 9, and 9 is not available, so we get a 2 in this cell. 11 is a sum. It won't be with a 9 plus 2 or 8 plus 3. It could still be 4 plus 7 or 5 plus 6. But now 5 here will need a 2 here for the product. So we can rule this out. And the only way of achieving 10 is to add 4 and 6 in here. Likewise, the only way to achieve 12 is to add 5 and 7. There are a 3 and a 1 somewhere in here. This 14 can't be 7 times 2, can't be 8 plus 6, so it has to be 5 plus 9. But the 5 here would need an 8 to have a sum of 13, and 8 is not available, so that's a 9. 9 plus 4, that's a 5, and that won't be 5 plus 10, it will be 5 multiplied by 3. This 4 here can't be a multiplication. It can't be 1 plus 3, so it could be a subtraction. It could be 5 minus 1, could be 6 minus 2, could be a lot of things actually. So let's move on to this 12. 12 won't be 9 plus 3, won't be 8 plus 4, won't be 7 plus 5. So the only way is to have a multiplication. It could be 2 times 6 or 3 times 4. And then only a big digit can work in this cell to provide this 13 with 6 plus 7 or 4 plus 9. But 7 for the 14 would need to be 7 times 2, and 2 is not available. So that's a 9, 9 plus 5, 9 plus 4, and 4 times 3. There has to be a 9 somewhere in here. And with those 8s, I get an 8 in here. 7 is not in here, it's not here, it's here. But this column still needs 1, 2, and 6. This column still needs 1, 3, and 6. So we have a 1, 3, 6 triple here. So 3 is in one of those two cells. And in this box, 3 is here. This is 1, 2, or 6. And those digits here must be 4, 5, 9 in some order. And then I think I can go back to the variance. This 8 looks interesting. It can't be 7 plus 1. It can't be 5 plus 3. It could still be 2 plus 6. 2 times 4, it can't be 1 times 8 or 8 divided by 1, but it definitely needs a 2. What about this 10 or this 12 perhaps? It won't be 3 times 4, it won't be 8 plus 4, won't be 3 plus 9, it won't be 5 plus 7 because of this, so the only way remaining is 2 times 6. And this 11 then is 2 plus 1, 9, 10 is 9 plus 1, and it resolves a lot in here. So this here is not a 9, so this here is a 9. For this 6 resolves the 4 6 pair, that's a 5, that's a 4, and that's a 7, and that's a 5, and this is really a sum of 11. That's 8. 6 here goes there, and this row needs 3, 5, and 6. We still need a 7 and a 6 somewhere. 6 is in here, so that's 1 or 7 because of this 2 and this 6. But this row needs 1, 7, 4, and 9, and this can only be a 1. 7, 4, and 9 in here. So the values here are 1, 2, and 6, the candidates. This 4 is interesting. It won't use the 1s, so it won't be 1 plus 3, 1 times 4, 4 divided by 1, or 5 minus 1. It won't be a product. It will have to be a difference, or 8 divided by 2. So that leaves a lot of options. This 6 now, it won't be 2 times 3, it won't, this 6, it won't be a difference because 9 minus 3 is not possible, 8 minus 2 and 7 minus 1 are not possible. So no difference, no division because of the 6 here, no product because 3 and 6 are not available, so it will have to be a sum. Either 1 plus 5 or 2 plus 4, but 2 is not available, so this is 1 plus 5. So there was a lot to consider in this case. The rest of the row is with 3, 4, and 9. So that's not a 3. Then this 5. So it won't be 1 times 5, it won't be 1 plus 4 because there's a 4 here. So the only way I think is to have 6 minus 1, and I really see no other way. Now this 4 will be 6 minus 2. There's a 4-9 pair in here. 6 minus 2, so this here is not a 2. 2 is here. It won't be 2 plus 6. It won't be 2 times 4. Ooh. So this 8 will have to be something else. And actually 2 is not here. 2 must be here. And this 7 is not 2 plus 5, it's not 2, it's 9 minus 2. So this 8 is 9 minus 1. This is the option that I haven't thought of. And it resolves a lot. So this is now a 4, that's a 3, and that's a 9, and that's a 4, and that's a 9. I need 6 is not here, so 6 is here. I need an 8 and a 5, so that's 5, that's 8. That's a 7. Here I need a 4 and an 8. Here I need a 4 and a 5 and a 7. Here I need a 1 and a 9. 5, 7, or 8. I need a 3, 3, 5, 7. And then in here, 8 and 3. Here, 2 and 6. But then, how do I get a 4 here? The only way is to have 8 divided by 2. And that should resolve a lot. No 8 here, so that's 8 and that's 7, that's 5, that's 3, that's 7, that's 5, and the remaining digits here we should have a 4, and that works, and a 7, and that works. So, well, when I pencil mark a 2 in those cells, that was wrong. Fortunately, it didn't mess up, it didn't meddle with all the rest of the logic. So I managed to find this red herring in time. So thanks to Nityant for those beautiful puzzles, both with the visual theme and the logic. And thanks for watching this video, and see you soon on SudoKanard.